Hey beautiful people, welcome to Math Doctor YouTube channel and I'm your host Amit. Today we will be discussing an interesting concept why 0 factorial is equal to 1 and we will also prove how 0 factorial is equal to 1. So let's start. As you can see the question is written here. So we will divide our question in two parts. First part is why 0 factorial 1 and the second part is proving how 0 factorial is equal to 1. This is, let's call this as part 2. So first we will start with the part 2. We will prove first how 0 factorial is equal to 1. So we will start with the basic definition of factorial. So we know that definition of factorial is nothing but, so if you are finding n factorial, then it will be n dot n minus 1 dot n minus 2 dot n minus 3, similar way up to 3 comma 2 comma 1. This is the basic definition of factorial. Now if you will see on the right hand side, if we exclude this n part, if we just for a time being, if we exclude this n part, this part, and take only this part, n minus 1, n minus 2, n minus 3, only this part, then if you will observe, then this is nothing but this is n minus 1 factorial only, right? So we can write the same equation as n factorial is equal to n minus n dot n minus 1 factorial, right? So this is the basic definition of factorial. Let's call this as equation number 1. Now we will put n is equal to 1 in equation 1. What we will get then? Then we will get 1 factorial is equal to 1 dot 1 minus 1 factorial, right? So on the left hand side 1 factorial, we know that 1 factorial is equal to 1, and on the right hand side 1 dot 0 factorial. Now we know that any number multiplied with 1 results into the number itself. So 1 multiplied with 0 factorial will result in 0 factorial. So here we can say that 1 is equal to 0 factorial. So this is the answer to our second part, which is 1 is equal proving 0 factorial is equal to 1. So this is the answer of our part 2. We proved, hence proved, right? Okay, so now still our first part is pending, which is our main part, you can say, and that part is part 1, and the question is why is 0 factorial as 1. Now before answering this question, we need to think a little bit beyond our logical reasoning, which how we solve the maths. So okay, uh, for making this question and answer, I need to give an example. So let's take an example first before that. So we know that 2 raised to power 1 is equal to 2. That means 2 is multiplied 1 times and it will result as 2. 2 raised to power 2 is equal to, that means 2 is getting multiplied 2 times. That will result in as 4. 2 raised to power 3 is equal to 2 getting multiplied 3 times. That is 8. And 2 raised to power 4 is equal to 16. That means 2 getting multiplied 4 times. 2 raised to power 5 is equal to 32. That means 2 getting multiplied 5 times, right? Then in this way, what will be the value of 2 raised to power 0? Now logically, what is 2 raised to power 0? That means 2 is getting multiplied 0 times. That means then there is no value because 2 is getting multiplied 0 times, no times, right? But we know that 2 raised to power 0 is equal to 1. Why? Isn't it the somewhat similar to why our basic question, why 0 factorial is equal to 1. Okay, so let's see an interesting trend here. So when we are going downward, from when we are going from 0 raised to power 0 to 1 to 2, 3, 4 and 5, when we are going downward, if you will say that increasing power, when power is increasing, the result is getting multiplied with 2, right? So I can write here result is getting multiplied with 2. So here result was 1, 1 got multiplied to 2, 2 got multiplied with 4, 4 got multiplied with 8, 8 got multiplied with 16 and 16 got multiplied with 32, right? Now if you'll go backward, then also, so from 32 to 16, so 30, when we are reducing the power, then result, the whatever previous result, so let's say 32 was the previous result, we reduce the power as 1, then result got divided by 2, 32 got divided by 2 is equal to 16, 16 got divided by 2 8, 8 got divided by 2 4, 4 got divided by 2 2, right? Till here I'm coming till here, so till here result is getting divided by 2, right? So similar way, if after this point also, if you will go upward, then if you will apply the same logic, that result is getting divided by 2, then 2 raised to power 0 will be the previous result, which is 2, it will get divided, the previous result as 2, probably let's take this. So when we are going backward, then so we know that 2 raised to power is equal to 2, and following this logic, result is getting divided by 2 when we are reducing the powers. Then if you will reduce the power from 1 to 0, then the previous result 2 will get divided by 2. This 2 will get divided by 2 and we will get the result as 1. And similar way, when we are going downward, when we are increasing 0 to power 1, then the result is getting multiplied by 2, then 1 is getting multiplied by 2, and which is true. So we can see here that this, when we are keeping the 2 raised to power 1 value as 1, then it is following a consistent trend which is meaningful also, somewhat meaningful. Similar way, similar way, similar way, let's see some factorial values. So let's say 1 factorial is equal to, we know that 1 factorial is equal to 1, 2 factorial is equal to 2, 3 factorial is equal to 6, 4 factorial is equal to 24, 5 factorial is equal to 120, 6 factorial is equal to 720, right? So if you will see here, when we are going downward, when we are going downward, the previous result is getting multiplied with the new number, the number of which we are finding the factorial. So 1, previous result was 1, now the number got increased by 1, then the new number is 2, of which we are finding the factorial. So 2 got multiplied with 1 and we got 2, then 2 got multiplied with 3, we got 6, right? So when we are going down, result is getting multiplied with the number, with the new number, isn't it? Similar way, if you will go upward, that from 6 factorial, so let's say if we have 6 factorial is equal to 720. Now we reduce the n which is was 6, from 6 to 5 we reduced by 1, then the previous number, previous result got divided by the number, the previous number itself. So for example 120, how we got 120, 120 was let's say, let's take this as stick. So how we got 120, how we got 120, previous number was 720, we got we divided this number with 6 and we got the 120, which is 5 factorial. Similar way, if we will go upward, Then 120 divided by 5, we got 24. 24 divided by 4 got 6. 6 got divided by 3, we got 2. 2 got divided by 2, we got 1. And in the similar way, if we will take 0 factorial, similar way, if we take the 0 factorial, then what it will be? Nothing but this 1 divided by, what is this number? 1. 1 divided by 1, that will become as 1. So hence, now you will ask, this is not a concept, this is more of a hypothetical situation, hypothetical proof, that here we got 0 factorial is equal to 1, 0 factorial is equal to 1. But see, maths is all about consistent formulas which are meaningful. So if you will put the value of, if you'll fix the value of 0 factorial is equal to 1, then it is satisfying this trend when we are going down, it is satisfying this trend when we are going up, and it is a consistent set of rule, it is following a consistent set of rule, and it is meaningful also. So when maths was getting developed, then mathematicians developed the maths in such a way that all the mathematical formulas are consistent with the other ones. So here we can see that even though, let's say, we might not be using 0 factorial is equal to 1 in our real life, we might not use it anywhere in the 0 factorial is equal to 1 in our real life, but still we set the value as 1 because we were it was following a similar, a certain pattern, a certain consecutive set of rules, and which is meaningful here. So similar way, if you will say similar way, like 0 raised to power 0 is not defined. So similar way, it was set as not defined because there was no set of rules it could follow. Mathematicians definitely must have thought about it, that if they can fix a value of 0 raised to power 0 or infinity or whatever, but they couldn't find any number, so they, which follows any certain set of rules, and which is meaningful, so they keep that as not defined. Whereas 0 factorial, as we proved here, that it is following a set of rules in this way, so they kept as 0 factorial is equal to 1. So this is the answer of our second of our part first, and why 0 factorial is kept as 1. So I hope you like the video. Do let me know if you have any other rationale behind proving why 0 factorial is equal to 1 and how 0 factorial is 1. Do let me know your thoughts in your comments. Thank you so much.